So that becomes of the single variable, the data descriptor. So next is the measures of correlation and regression, in which we can have the things in the two variables, minimum two variables. So minimum of two variables are involved in the correlation and regression. So in the correlation, we are making a, like suppose we'll take the example, the correlation will take the association between the two variables, how the two variables are related to each other. So correlation says that how they are correlated to each other, how the two things are related to each other. That is known as a correlation. Now, in the case of correlation, suppose we want to analyze what is the relation between the age and height of the individual. So we can say that there is a high correlation. So we can say that if the age and height are related to each other, the persons will age as the age and height. If the person age is more, the more or the less his height is also more. So we can predict a relation between these two, but we want to quantify it. We want to measure it. So we cannot rely on this line that it is low or it is high or whatever. We have to, if it is low, we have to define how much low. If it is high, we have to define how much high. The quantification we have to do it. We have to quantify the things. We have to quantify the things, whether it is a low or whether it is a high. So it is how much high or how much low. For example, I go to a particular shop to purchase a particular, like maybe a sweet shop or something. So then I make a weight of some sweets. We cannot say that it is a low weight or a high weight. We have to quantify that if it is a 1 kg, 2 kg, 1.5 kg. So we have to quantify it so that we can directly measure the weight out of it. So in that same case, we have to quantify our relation also. If the two things are related to each other or not, first thing, and if they are, then how much they are related to each other. So that will be signifies on that measures of correlation. So correlation will among the between the two variables, which will say that the measure of correlation will tell me that how these two variables are related to each other. If these two variables are how much associated with each other, the quantity will show, the measurement of the correlation will show that measures of correlation will tell that how much is the you can say the value will determine the relation between them. So that is your measures of correlation. So again, as we have did the example age of height, so we have to take the two datas. So we have to take the two datas for all ages and all heights. Maybe for maybe 50 or 60 individuals, we have taken the age and the height. And now we have to check whether these two datas are related to each other or not. So if we can see that they are having a positive relation between the two, and now the correlation can be of various types. It can be of like positive correlation or a negative correlation. Positive correlation says if the two variables are positively, like if one goes up, the others will also go up. So that is a type of your positive correlation, in which the two things are like in the same direction. For example, we'll take the another example of this, like petrol and car, the prices of the petrol and car. So this is the example of a positive correlation. If in case the price of the petrol will go down, sorry, this is the case of negative correlation, petrol and car. So negative correlation, how it is a negative correlation? Because if the price of the petrol will go down, the sales of the car will go up. So the price of the petrol and the sales of the car, they both are negatively correlated to each other, because as the petrol will price go up, the car becomes non affordable, so therefore the car sales will get down. So if the petrol prices are going up, car sales is going down, so they are in the opposite direction. So that's why it is a case of a negative correlation. But in case if you will take the example of a butter and bread, So bread and butter you will take. So bread and butter is an example, like if the sales of butter will increase, the bread will automatically get increase. So it is like the sales of bread and butter are like positively correlated to each other. One it get increased, other is also increased. One is decreasing, the other will also decreasing. If the any point of time the sales of butter will decrease, the bread will also decrease, because both the thing has to be consumed parallelly, simultaneously. So if the sales of one will decrease, the other will also get reduced. So, but one will increase, the other will also increase, the other will decrease, the other will also decrease. So in the same direction. So in case if the two variables are like related to each other but are in the moving in the same direction, it is a case of a positive correlation. And when they are moving in the opposite direction, one is going up, other is going down. So if that is the case, then it is a case of your negative correlation. So we have to measure it. So the measures of correlation values, if I'm talking of the measure of correlation, that always lies between -1 to +1. The value of correlation coefficient cannot be less than -1 and cannot be greater than +1. So -1 shows the perfect negative correlation. As the one increase, the other will decrease by the same amount. So that will show the
Excuse me, sir.
perfect negative correlation. Yes.
Sir, I have a question. This type of data will come in MST or in final paper or final exam of the
Like both.
pre-PhD?
So we are preparing like for the final examinations only, so it can be done in both also.
Yes, sir.
Both. It can be in MST and the final examinations also.
Okay, sir.
Yeah. So the correlation will tell me the extent of relation between the two things. So that will be the negative correlation or the positive correlation. And the third case may be your no correlation, when the two data are not correlated to each other. So that can be your third type of variation we have. Fine. So in that particular case, what we can do, so there can be the measures of correlation can be measured through three ways. So one is your like scatter diagrams. The first is your scatter diagram. The first method, that is to measure the correlation, the association between the two variables can be measured with the scatter diagram. The next is your rank, Spearman's rank correlation. Another method may be your Spearman's rank correlation. And the third one is your Carl Pearson's coefficient of correlation. So there can be three ways to measure this scatter diagram: Spearman's rank correlation and the Carl Pearson's coefficient of correlation. So these are the three ways in which we can measure our like correlations and correlation basically. So scatter diagram, the first one is the scatter diagram. Scatter diagram is none other than the like a graphical representation of the two variables. So graphical representation of the two variables are like, maybe on the one we have age. Suppose we have a age and height of the five, five individuals. So let's suppose the age is uh, 12 years, 13 years, 14, 15, and 16. So this is the age of the five individuals. Height may be like 150, 155, 160, 161 centimeters, and 165 centimeters. So suppose this is the height. So this is the data we can take for five, we can take it for 10, 20, whatever the number we can take. But the objective is we want to find the correlation between the two variable, like that is age and height. So how the age and height are related to each other. So that we want to find in this measures of correlation. So if we'll make the age and height and we'll make a graph out of it. So in one axis we'll take the age, on one axis we'll take the height, and we plot the data. So if we plot the data on the piece of a graph, so Yeah. So if we want to make the graph of the same, so there is like option of the scatter diagram also. So there is an option in the Excel that scatter diagram. So if we click on this and we'll use this graph. So this is your, so x-axis will show your age. So the x-axis will show the age. So this is the graph of this scatter diagram. So this is the scatter diagram we are getting as a result out of this graph, in which it is age is showing in the x-axis and height is showing on the y-axis. Why there is a delay? Okay. So so in that way, so in that way it is like, so in that way it is like this scatter diagram in which one is the height and one is the age. So this scatter diagram will show the these points, which shows that this is the increasing line. If we see this particular line, this is all in the increasing order. So this is your like the showing direct relation, in which we can say that the positive correlation, because the slope of the line is positive in nature. So if we join all these points, it comes as a, it comes like a straight line, in which we can claim that it is in a positive in nature, we can have a positive correlation. But suppose if we reverse this data, suppose the data will be like this now. So suppose we'll, so suppose we'll reverse the data. So let's suppose we have reversed this data now. So this becomes now negatively sloped line. So if we compare this particular slope now this is your negatively sloped. So on 12 it is the highest, then lower, and then it will become a, so it is now a negative correlation. So we can say that there is a age and height are negatively correlated to each other. As the age will increase, the height will in the decreasing order. So this slope becomes a negative. So that becomes your scatter diagram, in which the one and the other are opposite to each other. One is increasing and the other one is decreasing. Clear? So, but if we'll suppose the same data will take in a random way, there is no relation between the age and height. Let's suppose 140, then 150, 130, 149, and 150. Suppose this is the graph now. So on the age of 12, the height is 140. On the age of 13, the height is 150. So if we plot this, so it comes out to be no correlation, as it seems the points are in the random in nature. Some, but there is no straight line, no decreasing. So it becomes a case of your no correlation. But the thing is, it is a difficult to get the information out of scatter diagram, because in this scatter diagram the cases are like it is are randomly distributed. So if we want to make the information on this scatter, maybe somebody is saying that they are like on the positive line. So somebody may interpret it as they are not a positive correlation, but maybe a weak positive correlation, somebody may signify it. So it is having a like a case of, you can say, the subjectivity. What is the difference between the subjectivity and objectivity? Subjectivity means the different for all, and objectivity means the same for all. So objectivity, the science is like, if we see the difference between the science and art, that is a difference. Science is the objective study. Science means to have some rules and regulations which we have to follow in the scientific manner. If we doing the things with the particular rules, if it is same for me also and it is same for you also, so that is a objective nature. But in case of arts, it is a creative. I am doing my own creative and you are doing with your own creative knowledge and skills. So my doing way of doing the things and your doing way of doing the things are different. So that is the case of subjective. So the research should all be objective, because if research should be objective, because if I read the information or you read the information, it should be of the same thing. So then things should be in objective in nature rather than in the subjectivity. So the more objectivity should be there to avoid, and you have to remove this subjectivity from the research. So to have this in the problem of the scatter diagram is it give me the general information between the two things. But the problem in the scatter diagram is the different persons will interpret the information in different way. One will interpret that it is a positive correlation, weak positive, or other may interpret it as a zero correlation or so. Fine. So that is the problem in the case of scatter diagram. But scatter diagram itself says that we have to plot the two variables, and whatever the relation of these two, like graph between the two variables, if the graph of the relation will show a positive line or a negatively sloped line, accordingly we can say it is a positive correlation or a weak correlation or a zero correlation. So it can be a negative, positive, or a zero correlation, or in between that also. So maybe some values are like, take another example. If this is the data, maybe for four things it will be increasing, but for the last value it will be decreasing. So now this is, if we plot all these points, so it comes like to be, if we make a line graph on this. So let's try to make a line graph. But line graph will work on a single variable. So in case we want to plot the two variables, it has to be on the scatter only. But let's take, I delete this chart. So if we'll see this, if we'll join these 2 points, so if we make the joining of these points, so it becomes like this and drastically dip in the 16th here. So, but if we are taking this data, we can say that it is a positive correlation, not a perfect positive because of this point at 16. At 16, the data will be gets reduced to this level. So for that reason, we can say that it is not a perfect positive. But if we ignore this particular point, we can say that it is a positive correlation. So that is why it will be a weak positive correlation, we can say. But if we want to find the exact measurement, then we have to go to the either the Spearman's rank correlation or the Karl Pearson's coefficient of correlation. So Spearman rank correlation and Karl Pearson's coefficient of correlation will tell me the exact, like, what is the quantity. So as I have already told you, the coefficient of correlation lies between -1 to +1. So the Karl Pearson's coefficient of correlation and Spearman will tell me the value, that is if it is minus zero point 0.5, minus zero point 0.6 or zero point 0.5 or zero point 0.8 or zero point 0.9, whatever. So that will be signified with that particular quantity. So that quantity will signify if the value of the correlation coefficient comes out to be zero point 0.7. Suppose the rank correlation value or the Karl Pearson coefficient of correlation comes out to be zero point 0.7. So we can say that it is a high positive correlation, because zero point 0.7 is positive and zero point 0.7 is like towards 1. It can take a maximum value of 1. So zero point 0.7 will be closer to 1 value. So that we can say that it is a high positive correlation. If the value comes out to be like minus zero point 0.2, So we can say that it has a weak negative correlation because it is only zero point 0.2 and it is a negative. That's why it is a negative correlation and only minus zero point 0.2. So that means a weak negative correlation and all. Fine. So in that case, we can identify that what is the nature of the relation between the two variables and all. So that is your coefficient of correlation. Fine. So I'm stopping the recording.